Good afternoon. Yeah. Let's get settled down. Yeah. Okay. So warm welcome everyone to this late afternoon evening session on the impact of observational research, the latest science from RePORT International Consortium. So it's a pleasure to open this session. This session is organized by RePORT International with funding from the National Institute of Allergy and Infectious Disease of the US NIH. I'm Dr. Marissa Alejandria from RePORT Philippines, and with me is Dr. Sonali Sarkar from RePORT India. It's a pleasure for us to chair this session with you. So first, thank you to the Union Conference organizers for the opportunity to share with you the research that we do in RePORT International. RePORT stands for Regional Prospective Observational Research in Tuberculosis. So we are a global research consortium doing observational and translational research in TB. We do this through well-curated repositories of biological specimens linked to epidemiological data. So these specimens and data were obtained from the cohorts of people with active TB and close contacts that we recruited and monitored following a core protocol. So currently we have 8 member countries with a coordinating center at Rutgers University, USA. So the geographically diverse settings of our membership give us the capacity and the opportunity to study not so frequent but critically important outcomes of TB infection and TB disease with sufficient power and generalizability. So it's warm, and I'm happy to see familiar faces and colleagues to this session. So today our invited speakers will give us a snapshot of the spectrum of work that we do in our countries in the RePORT Consortium, as well as opportunities for collaboration. So first up, we'll introduce the speakers sequentially.
A very good evening to all. Thank you for joining us so late in the day. Many of us might have been really tired, long day, too many sessions. So it's my privilege to introduce my co-chair, Dr. Marissa Alejandria. She is the Executive Director of National Institutes of Health, UP Manila. She was recently the President of Philippine Society of Microbiology and Infectious Diseases from 2020-21. And Dr. Alejandria is the Principal Investigator of RePORT Brazil. My privilege to be here with you, Dr. Alejandria.
And equally privileged to have you as my co-chair. I'll introduce Sonali as when she comes up to deliver her talk. But then let's start off with our first speaker. We have Dr. Rajita Bhavaraju. Rajita is our Director for Global Operations for RePORT International Coordinating Center. So she will give us an overview of RePORT International, what has been done, current initiatives, and future directions. The floor is yours, Rajita.
Thank you. So I want to welcome you all here. It's good to see a good crowd of people so late in the day, as was mentioned up here. So you're going to see some science after this, people that are much smarter than me. So I wanted to just sort of set the stage about what RePORT International is. And so as was mentioned, it's the Regional Prospective Observational Research in Tuberculosis Consortium, or RePORT International. So before we discuss what RePORT International is, it's essential to understand what observational research is. So observational research includes studies where researchers collect information from participants or examine data that's already been collected. There are usually different cohorts with observational research depending on the study. For TB groups, we include healthy people, people with TB, or people at high risk for TB, such as close contacts. So why is observational research important for studying TB? First, we have the need for reliable biomarkers to predict the progression from tuberculosis exposure to active disease, as well as biomarkers to predict cure, relapses, treatment failure, and even mortality. However, most TB studies have small sample sizes, infrequent endpoints, geographic heterogeneity, and short-term follow-up. When coming up with better prevention strategies, diagnostic tools, and treatment regimens, observational research in TB helps us to understand the variability of the genetics of Mycobacterium tuberculosis and the human host, characterize early TB diagnosis, which can often be limited by traditional diagnostic methods, understand how M. tuberculosis circulates and why it affects hosts differently, and finally, we need to note the phrase that our director, Jerry Elner, has adapted from the late Yogi Berra, the baseball player: TB is not over until it's over. So we know that many people are, quote, cured from TB, but they also have significant post-TB sequelae, which observational TB research can shed light on. So these considerations have provided for the genesis and the growth of RePORT International. So RePORT was established in 2012 by the US National Institute of Allergy and Infectious Diseases, the Division of AIDS, and it was done in conjunction with bilateral support, including host country governments in high incidence countries. So phase 1 started in 2013 in Brazil and India, followed by South Africa in 2015. The Philippines and Indonesia joined in 2017, followed by Korea and Uganda. These 7 network countries are supported by the RePORT International Coordinating Center, which is now in its 3rd iteration and centered at Rutgers University in conjunction with Johns Hopkins University, Vanderbilt, and Fiocruz. So to contribute to the prevention, care, and elimination of TB, the goals of RePORT International encompass both epidemiological and clinical factors related to treatment outcomes, diagnosis, pathogenesis, and the long-term effects of having had TB. We're going to touch upon the last goal of capacity building a little bit later. So RePORT's 7 countries follow a common protocol, which is a minimum set of data and specimens collected for 2 cohorts. So cohort A includes persons with active TB, and cohort B includes people who have had contact with someone with active tuberculosis. The common protocol defines the collection of a participant's demographics and clinical characteristics, as well as specimen collection and the evaluation time points. Countries, however, may collect additional data and specimens that are relevant to their specific context. To date, there are over 631,000 specimens in the country's biorepositories from approximately 5,700 persons with active TB and 5,600 close contacts. If an investigator wants to do research, they can visit the RePORT website to find assistive tools, including RADAR, which is the RePORT International's data and specimen availability dashboard. So RADAR will assist in determining the feasibility of using RePORT data and specimens to answer specific study questions. There's also a data dictionary for the harmonized phase 1 data set, cohort A data, and currently RePORT is in the process of harmonizing all of its cohort B data, which is the close contact data, and it will result in a similar data set. RePORT study concepts also undergo formal scientific review at both the network and consortium levels. To date, RePORT investigators have published over 200 manuscripts encompassing a wide range of topics that align with the goals of the consortium. So the graphic, as you can see, illustrates the range of topics from epidemiology to immunology in diverse populations, many of which who have comorbidities. In addition to country-level studies, numerous cross-consortium studies involving 2 or more networks have been conducted and continue to be ongoing. These, again, touch upon both epidemiological and clinical factors related to treatment outcomes, diagnosis, pathogenesis, and long-term effects of having had TB. So the final goal of RePORT International is to address succession planning in planning for research, as well as directing research labs and research networks. RePORT has had a number of capacity building initiatives, including fellowships for early and mid-stage investigators, hands-on lab training, professional development and science-specific courses, and webinars on emerging topics, and our virtual learning room. The virtual learning room is an open access database that contains funding and fellowship opportunities, research job aids, educational tools, and other globally relevant resources. It can be accessed from RePORT's website homepage, which is reportinternational.org. So as you can see, there's a rich array of TB research that's been conducted using RePORT data and specimens. The speakers who follow me will highlight country-specific work. We do welcome external collaborations on the use of our data and specimens. So please visit our website and click on the Collaborate with Us tab to be guided through the research process. And you'll have assistance from a coordinating center staff throughout the entire process. We also appreciate collaboration on capacity building, whether it's through co-design training or utilizing our platform to share your programs with a broader audience through our weekly e-bulletins, monthly newsletters, our virtual learning room, and social media. So speaking of social media, we invite you to follow us on Facebook, Instagram, and LinkedIn, as well as check out our YouTube channel, which has a lot of archived talks that have been done by many of our investigators. The QR code up here will direct you to our website, but we've also included some handouts. Some of you might have already received them, and we'll also have them at the doors, which talk about RePORT International, so you can take that information home. And it also, on the back, has information about our sister consortium, FEN-TB. Thank you.
Thank you, Rajita, for setting the stage on what we do in RePORT International. So the Q&A session will happen at the end, after all the speakers. So may I now invite our second speaker, Professor Sonali Sarkar, my co-chair. Dr. Sarkar is Professor of Preventive and Social Medicine in JIPMER, Puducherry. She is the chair for the RePORT India Consortium. Dr. Sonali will speak on Beyond the Patient, Educational Disruption in the Wake of Tuberculosis. She will discuss the socioeconomic determinants of TB, focusing on educational disruption.
Thank you for the kind introduction, Marissa. Good evening again. So my topic, as Marissa has already said, it's beyond the patient. We have been discussing about the patient all the time, but there are a lot of factors that go beyond the patient. So that would be the discussion for me. This study has been funded jointly by NIH, USA, and DBT, Government of India. This is not new to all of us. We know the figure on the left side shows that the control of tuberculosis in the developed countries of the world the incidence had come down long before the advent of antimicrobials, which actually coincided with the improvement in the living conditions of the people. Coming back to 2025, what we have achieved thus far and the way ahead, the TB incidence rate as per the WHO Global TB Report 2025 shows that we have been able to reduce the TB incidence rate to 12% as against the target of 50% reduction by 2025. The number of decline in the number of deaths is a little more, that is 29%, but that against the target of 75% that had to be achieved by 2025. The percentage of TB-affected households facing catastrophic expenditure, which should have been 0 by 2025, we have reached about 47% in that target. So a lot is yet to be achieved in tuberculosis control, but TB being a social disease, there are a lot of factors outside of TB patient that need to be controlled to achieve elimination. So the social determinants have actually play a key role in the pillars of WHO's End TB strategy. They are part of the pillar 2. TB is a social disease, and its understanding is important as much as the understanding of how tubercle bacilli actually damages the human body. So how do the social determinants impact TB? The population groups who are at disadvantage because of being a lower socioeconomic group, belonging to occupations with higher disease risk, from ethnic minorities or sexual minorities or migrant groups, face higher risk of TB exposure through the intermediary determinants, that being the health compromising material circumstances such as poor housing conditions, poor environmental conditions, and also health compromising behavioral factors such as alcohol, drug abuse, and HIV. So these actually increase the health inequalities among the population groups, which increase the risk of TB and also the adverse outcomes of TB treatment, thus increasing the barriers further to accessing good care, good quality TB care. So we found that in our study from RePORT India, from about 2006 individuals with drug susceptible TB, Among the predictors of adverse poor treatment outcomes among TB patients, we found low education, poor nutritional status, and alcohol use to be strongly associated with the unfavorable outcomes. So we know about the social determinants of health in TB, but what are the gaps in the knowledge? All these factors, the determinants such as income, housing, environment, occupation, they are all interlinked. Nutritional status, all are interlinked, making a web of causation. What we do not know yet is the weakest link, which should be targeted to break this web. We also are not very clear about how do we define poverty, especially in TB-affected households. So among the list of questions that are still unanswered that come to my mind, the important ones is how well can deprivation be measured in TB households? What are the ways in which TB causes impoverishment, and which interventions can break this chain, the vicious cycle of poverty and tuberculosis? So we tried to measure impoverishment or poverty in our phase 2 of the RePORT India Common Protocol. We used the Global Multidimensional Poverty Index, in short we call it as MPI, which has 10 factors under the 3 domains, that is health, education, and living standards. We also included the Household Food Insecurity Access Scale, which has 9 items, which assesses the household food insecurity, and also the minimum dietary diversity for women, which assesses the consumption of at least 5 food groups of the 10 in the last 24 hours. So in the 9 sites across RePORT India, we enrolled participants who were assessed at baseline, months 1 and 2, end of treatment, and 6 months post-treatment, and 12 months post-treatment. So when we stratified our participants in phase 2, that is 594 TB patients, into deprived and non-deprived. Deprived being those who had multidimensional poverty index more than 33%. If the index score is higher, that means they are more deprived. If the score is lower, that means they are less poor, not deprived. So when we stratified them, we found that the nutritional status was very poor among the deprived patients. So the proportion with undernourished and severe undernourished was very high, as you can see here in the red boxes, among the deprived TB patients. These were the other characteristics of the patients, stratified as deprived and non-deprived. We did a multivariable analysis to find the association of the factors with MPI, as defined as more than 33. And we again found poor nutritional status, that is undernourished and severely undernourished, being very highly associated with MPI. When we tried to assess the reasons for impoverishment, the loss of employment we observed was more, and when we saw that before treatment and at the time of diagnosis of TB, what had happened to the employment. The figure in the left, the Sankey diagram, shows that the proportion which was unemployed had increased by the time they were diagnosed with TB. Some of the formal paid workers had become unemployed, but large numbers of informal paid workers had come into that unemployed group. We see that about 21% had lost their jobs by the time they were diagnosed with TB. 26 among the informal workers compared to 12% among the formal workers. The loss of days in wages was more among the informal workers, as you see. So informal workers who do not have the job security easily lose their jobs when they are sick and not able to go for work. Again, stratifying based on the individual income and household income, the bars on the left are the pink ones are those with formally paid jobs, and the blue ones are those with informal. The loss of income, you can see, was much higher among the informally paid workers. That was the difference. The individual income loss was about 6,000 among the informally paid workers as compared to 3,900 in the formally paid workers. So also was the household income. So it's not only the patient, the households, everybody is affected, and especially when they do not have a regular job with job security. and assessing the impoverishing health expenditure, which is defined as the proportion, the families which are pushed to below poverty line because of their out-of-pocket and catastrophic health expenditure when they have disease, when they are having tuberculosis. We found that 21% had been pushed to below poverty line overall. And again, when we stratified them as informal and formally paid workers, the large numbers here in the pen parade, you can see the red lines are those which show the patients who had gone below poverty line by the time they were diagnosed with TB. As compared to the black lines, the red dotted line is the international the line which shows the cutoff for poverty. And the black lines are the patients who remained above poverty line despite having TB. So this is, as you can see on the left, is the informal workers, which is more numbers than the formal workers. So informal workers, the impoverishment was much higher, that is about 22% as compared to 9% among the formal workers. And it was statistically significant. Again, when we compare what happened across the time points of follow-up, at the baseline, you can see the red bar on the top, the proportional bar graph, the red portion is not impoverished, the blue ones shows impoverished. So at the baseline, a larger proportion were impoverished as compared to the 6 months post-treatment. So most of the patients who were unable to go to work were probably functionally better. They had recovered and gone back to job and had started earning, and therefore the impoverishment had gone down. Again, this was because of the catastrophic expenditure and impoverishing cost, which was again higher in the patients with informal paid work. When we tried to see what happened to the households with educational disruptions, because when patients are the earning members in the households and they are not able to go to work, the older adolescents among the children in the family, they usually drop out of schools and colleges and they start working to support the family. So we found that the households which had experienced school discontinuation had an average MPI score of 38 as compared to the 30 among those without disruption. So these were the households which were poorer, which had multidimensional poverty, and the children were dropping out of school. So overall, there were 22 households which had 1 person dropping out of school. 3 households had 2 dropouts, and 1 each had 3 and 4 dropouts. That means some families where all the children had to drop out to support the family during the period of TB diagnosis and treatment for the patients. So what we found is that about 7% of the household contacts of people with persons with TB were affected by discontinuation of education. They were mainly the older adolescents and from families where parents had lower education, had informally paid jobs. And this proportion of disruption in education had actually come down 6 months post-treatment because the potential recovery from TB and the patients go back to job and the economic stress on the family eases. So overall, what we found was nearly 1/3 of our TB-affected households experienced impoverishing health expenditure, disproportionately affecting informal workers and vulnerable families, with a subset newly pushed below poverty line due to TB. We have seen this earlier. I mean, the studies have published from scoping reviews how the adolescents and children who drop out of school because of TB in their household have poor outcomes in their lives. So it increases child poverty, the children miss educational opportunities, they have reduced physical and emotional growth and also reduced mental well-being, which thereby increases their vulnerability to poor health and also to tuberculosis. And of course, they have reduced life opportunities, lesser opportunities to improve their living standards, and thereby this becomes a vicious cycle of poverty and tuberculosis, and not only the patient, the households, his or her children, everybody is affected, and thereby this is a concern not just for TB patients, but for the communities and societies. So what we know and what we have added by this study, the first 4 points are already known. What we add from this is that whatever existing social protection schemes we have as of now are definitely not enough. with households experiencing disrupted schooling, averaging MPI scores 8 points higher than those than the others. So it is important to target interventions to safeguard education of the children of the TB patients during the illness, and ensuring continuity of education for TB-affected households may be a critical strategy in economic stability of these families, and thereby helping eliminate tuberculosis in the long run. So these are some of the households of TB patients. If such are the conditions, are we doing enough? We need to do a lot more to improve the socioeconomic conditions and thereby make a greater impact on tuberculosis control. Thank you very much. Whatever I have presented today is an effort of a huge group that is called RePORT India Family. I'm just presenting on their behalf. Thank you very much.
Thank you, Sonali, for illustrating nicely and comprehensively the socioeconomic impact of TB, particularly on disrupted education, and highlighting also the gaps that we still need to address, no, particularly with regards to the socioeconomic determinants of TB. So from RePORT India, we move to RePORT South Africa. Our third speaker is Dr. Tom Scriba. Tom is a professor in the Division of Immunology, Department of Pathology at the University of Cape Town, and the Deputy Director of the South African Tuberculosis Vaccine Initiative. So Tom will talk on immunological signatures of asymptomatic TB, one of the recent ongoing initiatives of RePORT International. Yes.
Thank you very much, and well done for staying late. You are all TB fighters. So we've been interested in asymptomatic TB just like many others, and if you have visited any sessions today, I'm sure you've already heard about this. So we wanted to understand and use biological underpinnings to get a handle on what does the biology of asymptomatic TB look like, building on RePORT South Africa cohorts that we've been working on for a few years. So this is definitely not only my work, but many, many of us. I do have some conflicts. UCT, my organization, has received a number of grants to fund this and other work, and I'm also a co-inventor of biomarker patents. So the first thing that we noticed in studies that we've been doing is that when we look at people who are household contacts, we collect samples, sputum samples, if we can, from every single person, irrespective of symptomatology, and then test those for microbiological presence. We identified a whole bunch of people who have prevalent disease, or co-prevalent disease at baseline. And then when we looked at whether these individuals report symptoms, then we found that a staggering number actually don't. In fact, in the RePORT South Africa cohort B group, 82% of individuals said that they were not symptomatic. This is very similar to a previous clinical trial that we performed a few years ago now, called the CORTIS trial, where we screened people from around South Africa to enroll them into this trial where we used a biomarker of risk of TB, and amongst those who had high risk, randomized them to receive preventive treatment or not. And so again, in that particular cohort, amongst 2,923 individuals, there were 74 prevalent TB cases, and again, 85% of those cases did not report symptoms. At the same time, we also did an observational study amongst people living with HIV, which we called CORTIS-HR. This was not a trial, but a study in some ways similar to a RePORT. And again, there in that cohort, so there were 18 prevalent TB cases amongst 861 screened individuals, and 83% of people did not report symptoms. So when you look hard, and we managed to get sputum samples from virtually everyone, and tested the sputum irrespective of symptoms, one can find an enormous number of people who are asymptomatic but have disease. So based on that and these very valuable cohorts, we wanted to ask two key questions, or I'll speak to two key questions that we could address. The first one is whether we can learn something from inflammatory biomarkers in the blood about the heterogeneity and the nature of asymptomatic TB, and whether we can also identify subgroups amongst these. Are there different clear groups that may tell us something about the biology? And so a lot of this work is based on some work that we've done in previous years, where we looked at transcriptomic signatures in blood. For example, in this teenage cohort, the adolescent cohort study, we tracked people who progressed from kind of being healthy to developing symptomatic disease in this case. And so in red, you can see people who kind of transition through time in months, which in some individuals started 2 years before TB diagnosis, all the way through to 1 to 6 months before diagnosis. And you can see that this particular transcriptomic signature score increases amongst those as they progress to TB. In gray, we have individuals who had evidence of prior TB infection but did not develop disease. And you can see that this particular transcriptomic signature allows us to not only differentiate those who do not develop disease from those who do, but also allows us to track people over time. So these are the kind of analyses that we can do. And so we performed RNA sequencing, which I will mostly speak about. I'll speak about a little bit of proteomic analysis as well. In RePORT cohort A, so these are symptomatic people who present to clinics or healthcare facilities with symptoms, and then either turn out to have TB diagnosed on microbiology or did not, and those we call controls. And so we sequenced 220 individuals who were controls and 199 symptomatic TB cases. In the cohort B, and so these are household contacts, we selected from roughly 950 individuals, all those that had asymptomatic TB, so there were 46 of those. There were some that did have symptoms, and there were, but only 7, so remember that most of these individuals had asymptomatic disease. And then we selected some controls, 144 who also had PAX gene tubes that went for RNA sequencing. And then from the Cortis trial, there were also some asymptomatic TB cases from whom we could do some RNA sequencing, 27 of those, 6 symptomatic TB cases, and then a large group of controls who did not have TB. So one of the first things that we wanted to do is to look at this thing that is called molecular distance to health. So essentially, this is a calculation where you look at the entire transcriptome. You ask how many of the transcripts are perturbed or up or down regulated, and then you incorporate the degree to which those genes are up or down regulated. And some of you will be familiar with this study that was published in 2010 by Anne O'Gara and Matthew Berry, where they applied this in a British set of TB patients in red over here at the bottom versus those who did not have TB. They found lots and lots of genes were perturbed or up or down regulated, but when they then stratified those who had TB by radiographic extent of disease, you can see that this molecular distance to health increases in people who had more advanced disease. So it's kind of an interesting blood marker of how sick people actually are. So we applied that exact same tool. This work was led by Dennis Awani in our group. And in fact, there is a preprint out. If you search for Awani and bioarchives in 2025, you'll find the preprint. And so what we're looking at here on the left is the household contact screening cohort, so cohort B. We have the community screening cohort, Cortis, in the middle, and then we have the symptomatic cases from cohort A on the right. So let's start with the symptomatic on the right, and you can see that those who did not have TB have much lower molecular distance to health. Those who have TB have higher scores, so clearly reflecting the extent of disease. And that kind of situation is very well studied. What was interesting to us was that those in these screening cohorts, those who had asymptomatic disease clearly had an intermediate phenotype when we looked at distance to health. So the blue are these asymptomatic TB cases, and you can see that they sit between symptomatic and no TB. And the other thing that was interesting was, at least in the RePORT cohort, is that the symptomatic cases who are community dwelling, these are individuals who are running around, and when we asked them, do you actually have symptoms, they said, yes, we do. Well, they generally had lower molecular distance to health than the average person that actually is symptomatic and presents for care at a clinic. So that was kind of the first thing that was interesting. We see this intermediate phenotype, but it's very heterogeneous. They really, the group kind of covers an enormous amount of real estate on this graph. The second thing we wanted to do is to ask, well, what is the biological pathway or signal that we are seeing? And so I'm just showing you one of these. We performed something called weighted gene network co-expression analysis. Essentially what you do is you ask, well, are genes together in a correlated way either going up or down? And then you can select those genes and they form a module. So M3 is one of the modules that was perturbed, and you can see that when we look at controls, we look at asymptomatic TB and we look at symptomatic TB, whether that is in the community or in people who present to clinics, you can see that, again, the asymptomatic TB cases sit in the middle. And when we then asked, well, what is this module 3 in terms of the kind of pathways that these genes represent, then you can see that we have strong enrichment of interferon signaling, alpha beta signaling, cytokine signaling, and inflammation. And this will be very familiar to anyone who's looked at these kind of analyses before. So the typical type of inflammatory response that one sees in blood transcriptomic analyses. So the other thing that we wanted to ask is, well, do we see subgroups amongst the asymptomatic TB cases? And so here we combined the transcriptional data with some proteomic data. This was Luminix on serum. We looked at the very sort of typical 48-plex cytokine panel, and then asked, well, if we incorporate data from both those data sets, is there clustering amongst asymptomatic TB? And you can see that there is indeed some clustering. So we have this purple cluster and we have this orange cluster. This was pretty stable. We did some analyses to ask, well, how reproducible or stable is that? And they are actually pretty stable. It's not like this is just complete sort of spontaneous clustering. And we can then go back to some of the other data that we have from these people and ask, well, what does this clustering mean? So on this slide, I'm showing a number of microbiology readouts from sputum. You can see that the purple cluster has longer time to positivity on culture on the left compared to the orange cluster, cluster 2. The orange cluster tended to have higher smear positivity in those who had a sputum smear done. When we looked at expert MTB+, we also saw that there was a trend towards higher expert category in orange versus purple, although that was not significant. We also looked at quantiferon responses, and interestingly, cluster 2, which had higher microbiological counts in sputum, also tended to have higher interferon gamma levels in their blood in that assay. When we looked at BMI, they had a trend towards lower BMIs, perhaps indicating more severe disease. And when we looked at QAI scores, so chest X-ray severity, again, a trend. This was not entirely significant. And this is because we also didn't have X-rays on every single person, so it was a small sample size. So generally, it looked like that cluster 2, or the orange individuals, had more severe disease, higher bacterial loads in their sputum, which is an interesting finding. And in fact, when we align the asymptomatic TB cluster 1 or 2 with those who do not have TB and those who actually have symptomatic disease, again looking at RNA signatures, and here I'm just showing 2. The first one is the Sweeney signature, which is the basis for the Expert HR cartridge, and the one on the right is actually a signature that was identified in the mouse and is protective against TB in the mouse, so it kind of indicates perhaps in humans the degree to which humans are susceptible to TB. You can see that cluster 2, which had the more severe phenotype, looks a lot more like symptomatic TB, and cluster 1 looks much more like people who don't actually have TB. So clearly, everything is sort of pointing at this more severe and less severe cluster. And so I'll leave it at that and just give you some take-home messages from this work. First of all, asymptomatic TB is very heterogeneous. In fact, I would argue it's a spectrum within the spectrum. And of course, these are still pretty limited sample sizes, and it would be really interesting to see in much, much larger sample sizes whether there are actually indeed more subclusters than just 2. But we do find these 2 subclusters in this particular analysis, and it likely represents sort of different disease severities or bacterial loads. Of course, this raises some really interesting questions that we are not capable of addressing right now, but one is about infectiousness, and for those of you who were in the previous session about asymptomatic TB, this was a very important discussion point, and we had some really nice modeling done on this. It may be that the more severe cluster is more infectious than the less severe cluster, but that's, of course, speculation on my part. And then another question about whether one cluster may be more likely to progress to symptomatic disease than the other one, or whether one cluster might be more stable, and perhaps these are individuals who could maintain an asymptomatic state for longer. So lots of questions, as usual, in the realm of TB research. But I think it does inform ways in which we can study asymptomatic TB, and hopefully leads to many more studies that help us to understand more. And so I'll end there and thank the many, many people in RePORT South Africa and RePORT International. RePORT South Africa is led by Mark Hathrell, who I believe may be in the room, I'm not quite sure. Oh, he is, excellent, sorry. It's very bright over here. Many others, including Dennis, who did most of the transcriptomic analyses, Simon Mendelsohn, Dominique Arifdin, Virginie Rousseau, who co-supervised Dominique, and many other collaborators, and of course the entire network in South Africa. It's not only in Cape Town, but in a number of other provinces. Thank you.
Thank you very much, Tom, for sharing those very interesting findings. As you rightly said, there are more questions than the answers as of now for asymptomatic TB, and we just heard from the previous session on ATV. So, but asking the right questions is, I think, the first step to getting the answers. And it's very interesting to know that there's so much of heterogeneity within the asymptomatic TB, and further research will probably throw some more light on it. And there will be more discussions, I think, at the end. So our next speaker is Felipe Ridolfi from RePORT Brazil. He received his medical degree from Brazil and his PhD from, sorry, I may not be pronouncing it correctly, the University Fiocruz in Brazil. He is currently performing a postdoctoral fellowship in Vanderbilt University Medical Center in the United States. Dr. Ridolfi presented work recently at the CROI and was awarded the postdoctoral early stage research and professional development fellowship from RePORT International. He is going to talk on the treatment of HIV-related TB. Insights from RePORT Brazil. Over to you.
Right. Thank you very much, Dr. Sonali, for the kind introduction, and thank you for staying so late. So today I'm going to give you an overview of the HIV-related TB in RePORT Brazil, and I have no conflicts of interest to disclose. So as I said, we're going to talk about the treatment outcomes, then adverse drug reactions. We're also going to relate the adverse drug reactions to the pharmacogenetics, human genetic ancestry, and the adverse drug reaction, antiretroviral therapy, the human genetic polymorphism, and the HIV-1 virological suppression. And finally, we're going to talk about the standard TB regimen, the fixed dose combination, and the population pharmacokinetic study that's being developed. So for all these studies, we included participants from RePORT Brazil that were drug susceptible and used the standard TB treatment regimen, and of course, for pulmonary TB. So starting with TB treatment outcomes, in this study, we evaluated the baseline factors associated with the different components of unsuccessful TB treatment outcomes. Okay. Thank you. So successful TB treatment was defined as curing treatment completion, while unsuccessful TB treatment was treatment failure, death, and loss to follow-up. Here included 915 participants, being 19% of them people with HIV. 79% of the participants achieved a successful outcome, and 21% had unsuccessful outcomes. 13% of them were lost to follow-up. Here is the coefficient plot of the factors related to unsuccessful outcomes. Here I'm just displaying the HIV. So you can see that HIV was related to the increased odds of all unsuccessful outcomes. When you look at the HIV-related factors, we can see that the higher the CD4 cell count, the higher the odds of loss to follow-up. So here, the increase in CD4 cell was per 100 cell and the higher was the odds of loss to follow-up. Continuous on treatment outcomes, this other study, we evaluated the weight change 2 months after TB treatment initiation by HIV status and the association with unsuccessful TB treatment outcomes. 547 participants were included, and again, 19% of them were people with HIV. 6% of them had an unsuccessful outcome, and people with HIV gained a median of 1.3 kilo less than the HIV seronegative individuals. They were also in an increased risk of unsuccessful outcomes, and overall, the risk of unsuccessful outcome was decreased by 12% as there was 1 kilo increase in the weight. Now moving to the adverse drug reactions field. Here we developed prediction models for adverse drug reactions occurring during TB treatment. We included in this study 945 participants, and 11% of them had an adverse drug reaction. Overall, there was 156 TB treatment-related adverse drug reactions, most of them occurring during the intensive phase of TB treatment of grade 2 and of hepatic organic system. HIV status increased the risk of adverse drug reactions, and when we develop a nomogram with all the variables related to the risk factors for adverse drug reactions, we can see that the HIV was also included. So the fact of you being a person with HIV, you gain 10 points in this nomogram. When you look at the risk of adverse drug reactions through the time, we can see that people with HIV have a higher risk of adverse drug reactions. And here, the coefficient plot of the factors related to adverse drug reaction. Again, HIV is a risk factor. When you look at the pharmacogenetics and the adverse drug reactions, in this study we evaluated these genetic variants, treatment toxicity, and treatment effectiveness. So 908 participants were included, 18% of them were people with HIV, 14% of them had an adverse drug reaction, grade 2, and when we compared people with HIV and HIV seronegative, we can see that there was a difference in the incidence of adverse drug reactions of recurrence. 4% of them had a treatment failure or recurrence, and when we compared people with HIV and HIV seronegative, there was no difference in this proportion. And interesting, in this study, 51% of the participants were NAT2 slow acetylators. And when we correlated the NAT2 acetylator status with the risk of adverse drug reactions, we can see that the NAT2 intermediate compared to the rapid metabolizer, they had a higher odds of grade 2 or higher adverse drug reactions and the TB treatment hepatic adverse drug reactions. And when you look at the NAT2 slow metabolizer, we can see that this effect is even more pronounced. So grade 2 or higher adverse drug reaction, grade 3 or higher, and TB treatment-related adverse drug reaction. Now talking about the human genetic ancestry and adverse drug reaction. In this study, we evaluated the genetic ancestry proportion and its association with the risk of adverse drug reactions. So 930 participants were included and genotyped. 11% of them had a grade 2 or higher adverse drug reaction attributed to TB treatment. and people with HIV represent 19% of the study population and had an average of 41% of European ancestry, 19% of African ancestry, and 33% of Amerindian ancestry. When we look at the risk or the odds of adverse drug reaction according to the ancestry proportion, we can see that the higher the proportion of African ancestry, the lower the odds of adverse drug reaction. And there was an interaction with HIV status. And when you look at the European ancestry, the higher the proportion of European ancestry, the higher the odds of adverse drug reactions. But here, the HIV was not significant, included as an interaction. Moving forward, now we're going to look at the human genetic polymorphism and the antiretroviral metabolism. So here in this study, we evaluate the association between the human genetic variants associated with the antiretroviral metabolism and HIV-1 virologic suppression. So our endpoint of interest was virologic suppression, and we compare the non-nucleoside reverse transcriptase inhibitors, here represented by efavirenz, compared to the integrase strand transfer inhibitors, here dolutegravir and raltegravir. We perform a survival analysis and a time to virologic suppression, and also Cox regression. So this paper is under review. We just submitted last week the response to the reviewers. And here we compare the CYP2B6 genotype, which is related to efavirenz metabolism, and the UGT1A1, which is related to dolutegravir and raltegravir. Both are characterized as normal, intermediate, and slow genotypes. So 109 participants were included, 94 were included, and overall there was a suboptimal virologic suppression. So 68% of the participants achieved virologic suppression. 76 participants used efavirenz, and most of them were CYP2B6 intermediate genotype, and 88 participants used raltegravir, and 48% of them were of normal genotype. Here we can see the time to virologic suppression according to the genotypes, and we can see that there was no difference among the UGT1 genotypes, neither among the CYP2B6 genotypes. So there was no statistically significant difference in the virologic suppression proportion and the time to virologic suppression according to the genotypes. However, when we did a Cox regression, we found that the higher the baseline CD4 cell count, the higher the odds or the hazard of virologic suppression, which makes sense. And the higher the baseline HIV-1 viral load, the lower the hazard of virologic suppression. And finally, talking about the population pharmacokinetics, this is a study that we've been developing, and we have ongoing analysis. We are going to develop a POP-PK model for each of the standard TB treatment with real-world data. So in RePORT Brazil, we have the samples collected and measured for all the 4 drugs, and we are running these models. So I bring you some preliminary results. So for this study, we used the fixed dose combination regimen and 1 POP-PK model for each of the TB drugs. In RePORT Brazil, we have the sparse sampling in baseline, month 1, month 2, and the end of treatment. And for this study, we're going to use the month 1 samples. And the proposed PK model that we are developing through Monolix and Chusimux is an oral administration, first order absorption, 1 compartment, and linear elimination with clearance. So we use the Monolix for the model building and the simulation, the Simux for the simulations. So when you look at the factors related to each of the PK parameters, so for this model we have the Ka, which is the constant of absorption, Vd, which is the volume of distribution, and Cl, which is the clearance. So for each of the drugs, we have different factors related to each of the PK parameters. So I highlight here the HIV was included as a factor impacting the constant of absorption for rifampin and for the volume of distribution of PZA. And when we use this model in Simux to look at the predicted concentration, we can see that by stratified by HIV status, people with HIV have a lower predicted concentration compared to HIV seronegative for rifampin. When you look at the PSA, the same, we find that people with HIV have a lower predicted concentration compared to HIV seronegative. So these are preliminary results. We're going to refine the models, but I think these were the most interesting findings to demonstrate to you today. So to conclude, you may ask, okay, Felipe, so what's new? So we can say that we confirmed prior findings in the HIV-associated TB, higher odds of all successful outcomes and risk of adverse drug reaction, the lack of gain weight and the unsuccessful outcomes, the baseline viral load and the CD4 cell count impacting the HIV-1 virologic suppression, and the natural profile associated with the odds of adverse drug reaction. However, I would like to highlight that this new finding about the ancestry proportion, the risk of adverse drug reaction and the interaction with HIV. So the higher the African proportion ancestry, the lower the odds of adverse drug reaction, and the higher the European ancestry proportion, the higher the odds of adverse drug reaction. And ongoing conclusions, as I mentioned, so the impact of HIV on first-line TB drugs pharmacokinetics. For now, we have that rifampin is impacted by HIV and the constants of absorption and the volume of distribution for pyrozinamide. And I would suggest for future directions and interventions that we may address and encourage the weight gain during the TB treatment and some potential for personalized and or stratified TB treatment according to the natural acetylated profile, especially the slow metabolizers, the genetic ancestry proportions, and the individual PK parameters once we have more robust results. So I'd like to thank you, the participants, thank you all the team involved in these many studies, and thank you very much.
Thank you, Felipe, for presenting so many studies in a short time. I think there will be a lot of questions we'll take at the end. Our next speaker for the day, the last speaker, is Dr. John Carlo Malabad. He's from RePORT, Philippines. He's a junior physician scientist working on the molecular epidemiology of genomics of Mycobacterium TB in the Philippines under the RePORT International Consortium. He's a graduate of MD PhD program of the University of Philippines and is currently an adjunct research faculty of the National Institute of Health, UP Manila, and is an assistant scientist of the Department of Science and Technology. So he is going to speak on the TB recurrence and progression to active TB, burden, determinants, and implications on TB prevention and care.
All right, good evening, everyone. Thank you all for staying. It's a challenging task to be the last speaker of the day, but I promise not to hold you a little longer than we should. But thank you so much for staying. Let me just share with you the work that we do in RePORT Philippines as an active member of the RePORT International Consortium. As mentioned by Dr. Sonali, I will be focusing on the work that we do on tuberculosis recurrence as well as progression to active tuberculosis. Now, these are not just the works that we do, but this will be the focus of the presentation for today, and it's such an honor to be part of this symposium as well as the World Conference on Lung Health in general. I declare no conflict of interest to report. Now, the Global TB Report 2025 has just been released, and I know all of you know already. Let me just share with you the burden of TB in our country. While not so much improvement in terms of the number of the decrease in the incident cases, that is also seen in our numbers in the Philippines. However, when we look at the incidence rate, we're still above 600 per 100,000 population. And we belong to the top 3 of the highest incident cases. But in terms of the number of the incident cases, we are 3rd. In the previous years, we are 4th. So this is an unwanted promotion to us. Okay. Now, in terms of the WHO list of high burden countries, Philippines is one of the 10 countries that has high burden, not just for TB, not just for drug-resistant TB, but also for TB HIV co-infection. And that speaks a lot about the burden of the disease in our country. And we are so fortunate that we are part of the RePORT International Consortium. There are a lot of study groups in the Philippines doing work on TB in many aspects of TB research, but being part of the RePORT International Consortium has done so much to us in terms of capacity building, in terms of doing research initiatives to help in the TB control and prevention initiatives. Now, RePORT Philippines consists of two sites, the UP Manila National Institutes of Health and the De La Salle Medical and Health Sciences Institute. The main difference of the two sites is that the UP Manila site focuses on drug-susceptible TB, while the De La Salle site focuses on drug-resistant TB. But both sites maintain the cohorts A and B, cohort A being the active TB cohort, and the cohort B, the cohort of household contacts of those enrolled in cohort A. In terms of the samples that we are collecting and we are storing in our biorepositories, we are basically storing the same sets of samples. In terms of site, we are both involved in the southern part of the Luzon Island in the Philippines. So if you look at the capital, which is Manila, part of the National Capital Region, the De La Salle site is recruiting TB and household contacts of the TB participants from the province of Cavite, which is part of the southern Luzon. And we at the UP Manila is recruiting participants from Laguna, which is also a high TB burden province in the southern part of Luzon Island. So that's those are the differences of the two RePORT sites. Now, being part of the RePORT International Consortium and following the common protocol of RePORT International, we also have these groups of participants. So we have the healthy household contacts. These are the household contacts of cohort A participants who were negative for both IGRA and the tuberculin skin test. Now we have the latent TB group who are household contacts of the cohort A participants but positive for either IGRA or TST or both. Okay? Then of course we have the active TB cases in our cohort A, and we have a small group who started from cohort B who developed during the monitoring period to have active TB. Okay, so those are what we term progressors. And we are following up for their outcomes. For cohort A, that's 2 years after they end their treatment. And for cohort B, that's 24 months or 2 years from the time that they were enrolled to the cohort. And like what I mentioned, we have a lot of studies that are being done in the Philippines right now. Thank you very much to RePORT International. But I'll just be highlighting these three studies for the purpose of this presentation. So let me start with the long-term outcomes of active TB patients. So we are working closely with the local national TB control program of our local government unit. So they refer to us the newly diagnosed TB cases. So during the study period, which was 2018 to 2022, there were 1,597 diagnosed with active TB from the local NTP. And out of those, 779 were enrolled and 601 completed follow-up. Now, for cohort B, we invited the household contacts of those in cohort A because that's a requirement. There were 2,404 household contacts, and out of those, 905 were enrolled to cohort B, and 744 of them completed follow-up. Now, of course, there are some people who did not consent to sample collection, so we don't have biobank specimens from these, and they were not part of the RePORT cohort that we are maintaining. But at least we have 575 cohort A and 686 cohort B with biobank specimens that are waiting to be studied, and we can do more studies on these different groups of TB patients and different TB status of these individuals. Okay. Now let me share with you the socio-demographic and clinical profile of those that have been recruited to cohort A. Majority still male, 59%, and they belong to the economically active age group. 83% were new cases. That means 17% have history of previous TB or previously been treated for TB. We have 11.5% any type of drug resistance. That includes MDR, monoresistant, polydrug resistant. Okay, in the Philippines, BCG vaccination coverage is very high. So in our cohort, 85% BCG vaccinated. There's a good proportion also of underweight, 11% with diabetes, 44% were smokers or either previous smokers or currently smoking, okay? And 21% have hemoglobin levels below normal. Now, we classified those new diagnosed cases and those who have been previously treated, and we looked at their treatment outcomes, either favorable or not favorable. When we say favorable, this includes bacteriologic cure, treatment completion, and clinical response. For non-favorable, this includes bacteriologic or clinical recurrence, bacteriologic failure, death, as well as treatment incomplete. And if you would look at the percentages of favorable and unfavorable between these two groups, you would see the difference. So there's higher favorable outcomes in patients or in the group who are new cases of TB compared to those who have been previously treated. And in terms of unfavorable outcomes, we saw more of these outcomes in the group that are previously treated with TB. Okay, so the death, the percentage of death, the recurrence are higher in the retreatment cases group compared to the new cases. All right. Now, we studied some of these participants in the cohort. We looked at biomarkers for favorable treatment response. 150 of them consented to join the study. 78% were male. The median age is 44 years old, and 86% of them were new TB cases. 13% with diabetes, and out of the 150, 82% with favorable outcomes. Now, we studied these individuals with favorable outcomes. We collected serum samples in line with the time points of collection of the RePORT International Common Protocol. So at baseline, month 1 after treatment initiation, month 2 after treatment initiation, and end of treatment. Out of 11 cytokines, with the help of our colleagues from RePORT Brazil, led by Dr. Bruno Andrade, Dr. Mariana Pereira, and Dr. Arthur Quieros, we were able to analyze their cytokine levels at different time points, okay? And we saw that out of the 11 cytokines that we have studied, 5 showed decreased trend in terms of cytokine level, and that includes IL-6, IP-10, interferon gamma, SIL-2RA, and IL-27. MCP-1 showed an increasing trend of trend levels from baseline up to end of treatment. Now, this reflects a generally weakened or dampened immune response as a reflection of the decreased mycobacterial burden due to effective treatment. So it shows a favorable response or treatment response to the anti-TB treatment. Okay, so which is a good thing. And if we recall all these cytokines, the 5 cytokines that are significantly showed significantly decreased trend are inflammatory markers or cytokines. Okay. Now, through the help of RePORT Brazil, we were also able to do a network analysis of the inflammatory profile of these participants with favorable treatment response. And we saw that there's a more coordinated response at the end of treatment. If you look at the network density from baseline up to the end of treatment, you see the increase in the network density, which reflects the more coordinated immune response of these participants. Okay. And that's also attributable to the favorable treatment response seen in these participants. Okay, so that's for biomarkers for favorable treatment response. Now, in our cohort, we also have cases of TB recurrence. Prior to their enrollment, or at the time that they were enrolled to RePORT Cohort A, 103 individuals have already history of previous treatment. Okay, that's 17% of our recruited participants in Cohort A. Now, during their time or monitoring period of 2 years after treatment, 13 of them develop another episode of TB. So that's TB recurrence that we have classified. So we have the recurrence rate, okay, before the study entry is 13.7 per 100,000 person days, and while during the study, it's 2.76 per 100,000 person days. Now, I won't be sharing any biomarkers for TB recurrence because in RePORT International, we are doing a cross-consortium project that studies biomarkers associated with TB recurrence. Okay, so we will be sharing with you once we have more data to show. And RePORT Philippines is part of that cross-consortium project. Okay. So let me now proceed with you. Let me now proceed with TB progression. Out of the 744 cohort B participants that we have recruited, 78 of them developed active TB during the course of the monitoring period, while 666 did not. So this means that the TB progression rate in our cohort is 16.8 per 100,000 person days. Now, to share with you the socio-demographic and clinical profile of these progressors, 41 of them were male, 88.5% were age 18 and below, okay? So majority of our progressors were really children, okay? And in our regression analysis, the ones in red were the ones associated with TB progression. So that's age below 18, okay? Low household income, and a low BMI or being underweight. Okay, so we have a good proportion of our progressors being underweight. Okay. Now, not all of our progressors consented to sample collection. And since majority of our TB progression cases were pediatric cases, we focus on studying biomarkers for TB progression. So we studied 33 progressors, pediatric progressors, and compared them with 50 non-progressors. In terms of age and sex, there's no statistical significance between both groups. And we did cytokine analysis of these groups, and we found out that IL-12 and IL-32 alpha are the ones significantly associated in terms of significantly different between the two groups. And we noted that there is a lower level of IL-12 and IL-32 alpha in the progressor group compared to the non-progressor. And actually, this is consistent with literature because if you can recall, IL-12 and IL-32 are considered to be protective cytokines. So they protect, okay, their action is more on antimycobacterial. So they protect the host from developing TB. Okay, so when the levels are low, the progression becomes, the risk of progression becomes higher also. So that's for the biomarkers that we identified for TB progression. Now, to highlight what has been presented and to highlight and summarize what has been presented, to our knowledge, these studies that I have presented today are the first to involve cohorts from the Philippines. And like what I mentioned, these are just few of the things that we are doing. And the data from the Philippines can contribute to the growing data, to the growing global data on factors and biomarkers associated with TB recurrence and progression. Through the funding from the Korean National Institutes of Health, USNIH, and CRDF, we are also doing RNA sequencing, studying progression from using our cohorts, so that can add to more data that we can use to collate data from RePORT International network countries. Okay? And in terms of potential biomarkers for favorable anti-TB treatment response, we saw significant decrease trend in the levels of IL-6, interferon gamma, SIL-2R alpha, and IP-10. While for TB progression, we saw that there's the biomarkers associated were IL-32, IL-12, IL-32 alpha, IP-10, although it did not reach significance, but if you saw the level from the table, you can see that there's also higher IP-10 levels among progressors. All right? And with all these things, they present opportunities for collaborative TB biomarker validation and diagnostics development. Now to end, I'd just like to share the implications on TB prevention and care of all these things that have been shared. why treatment response monitoring is important, while TB progression identification is important and all that. So TB treatment response monitoring aids in timely intervention so that we can prevent unfavorable outcomes to those who have been undergoing TB treatment. And when we identify contacts with high risk for progression, we can also, this can also help to craft strategies for better TB prevention and control. And we can monitor them so that they can be prevented to progress to active disease. Okay? One of our realizations from everything that we have done and currently doing, there's a need to strengthen post-treatment surveillance, enhance diagnostic algorithm, and integrate social support within the TB control program that we are implementing in the country. Now, all these things are not possible without these wonderful institutions, organizations, and teams. So I just like to acknowledge our Philippine government for the funding, the US NIH as well, and CRDF Global, and the funds that we have received from the Korean National Institutes of Health. We are very happy collaborating with the RePORT International Consortium, with RePORT Brazil, with our local government unit, as well as with Rutgers University. And these are the people who are actively and hardworkingly involved in the work that we do in RePORT Philippines. Maraming salamat. Thank you very much.
Thank you, JC, for nicely summarizing all that work that has been done under RePORT Philippines for both the cohorts. So we are now open for questions for all the speakers. While you think of questions, I have some questions. Can I start with Tom? Tom, that was very interesting about the, yeah, please. You said that you are able to find different clusters among the asymptomatic TB cases, and they are distinct in so many immunological ways, but were there differences in their clinical and other characteristics like comorbidities and BMI and many other clinical factors? How heterogeneity is related to those clinical factors?
So we looked at a whole bunch of things. The ones that stood out were BMI, where it looked like the more severe group had a lower BMI. So HIV was not a factor. And so other than the microbiological BMI, the interferon response, and the chest X-ray where there was a trend, there were no others that really stood out.
Comparison was done, but nothing was found to be different. So have you ever considered about trying to see the pathogen factors and in the differences?
Yeah, we have not done that yet. So that's something that could be done. We have cultures on many of those, and so we could look at strain for sure.
Thank you. Any other questions for Tom while he's here? Yeah.
You can stand here. And you might as well answer your own question then.
So you have different numbers of people that you select. You use that word, and I just got curious about that. So how you selected those samples, right? Because you could do that trying to do some matching or not. So what was the approach, and if that could influence your results, right? You have discrepancies in the numbers of people in each subgroup, and why we need to understand that, because then many of the differences could be just behind the scenes and we haven't captured.
Yeah, great question. So the cases were selected. We basically did all cases that we could. In the Quartus trial, we did a high throughput PCR type approach, and we did RNA sequencing, RNA extraction using a robotic platform. And so the RNA we got wasn't as good as manual extraction. And so even though there were many more cases, we only had 27 for whom the RNA quality was sufficient to do RNA sequencing. So that was entirely technical based on the sample. And then we selected controls. And I need to go and check to make sure it's exactly right. For RePORT, we didn't match controls to cases. We did a selection, like a random selection, and then just made sure that there was no imbalance. For Cortis, I think there was some matching, if I remember correctly, but I'll have to check and let you know. But either way, when we then looked at, sex, age, there were no significant differences between controls and cases.
Any other questions? Ivan has a question.
So Tom, just a question. I mean, excellent data, pretty exciting actually. So when you did your analysis, did you look at, you had RNA-seq, you had all kinds of other data sets. Did you look at each factor individually, or did you do kind of a multi-factor kind of analysis across different modes of data, like a multimodal type of analysis? Anything like that?
You mean for the clinical data?
Combining the clinical and the genomics and all of the other kinds of data together?
No, we have not done that yet. So Simon has actually looked at so for RePORT at least, he's looked at, the clinical description of the cohort, so that's in his paper. And then we did these sort of biological biomarker type analyses separately. For the clustering, we then brought back just to ask, well, are there differences between the different clusters that might explain what's going on? But we haven't tried to, for example, build a predictor that incorporates clinical and biological measurements, which of course could be done and perhaps would be very interesting.
Just another question. How many of these patients can be followed up? I mean, because there were questions about we don't yet know the natural history, whether they are put on treatment. So there's so much of heterogeneity, but what happens to the outcome exactly? Do they match with the clinical outcomes, or is this an important factor?
Yeah, so the asymptomatic TB individuals were referred for treatment, and so we did not follow them up to see, if they would become symptomatic, for example. And that's done in the public health sector at clinics. And so our study did not include follow-up to see how they respond to treatment or anything like that. That's certainly something that should be done in future.
But that's an ethical issue also. Like, you cannot not treat them, but when you treat them, you don't know what happens otherwise. So it's a double-edged sword. So difficult.
I'm sure there's questions for others too.
Yeah, let's release Tom.
Yeah. So are there other questions for Felipe, JC? I'm always here.
Yeah, hi. So just thanks for the sake of variety. My question is to Felipe. So you did one of your conclusions was interesting. So sort of to look at weight gain as a predictor for poor treatment outcomes. Yeah. Did you have you looked at weight gain stratifying by their baseline BMI? So in other words, if they present with low BMI, do you think that they just have more weight to gain in response? Or is it independent of baseline BMI status?
Well, this paper was led by Lauren and colleagues, and as I know, the weight was handled as a continuous variable. So as the weight increased, the risk of adverse drug reaction, unsuccessful treatment outcomes decreased. But we saw in the other presentation, and we see that the low BMI is associated with worse TB treatment outcomes. So maybe we can address that. But in this paper, the weight was handled as a continuous variable.
I have one question for JC. JC, I didn't see HIV because you were saying you have high prevalence of HIV as well in the beginning background. But in your presentation, patients, I mean, were there differences in the biomarkers based on the HIV status? Or?
In Report Philippines, we only have 1% of our cohort are HIV positive. Yeah, and for the biomarker analysis that we did, we intentionally exclude the HIV participants. The numbers are low for HIV.
I have one question for. Yes.
I think Thomas will have to answer this again. We just heard papers in the other room regarding recurrence of tuberculosis declared cure. And there were recurrences both asymptomatic and symptomatic. Will your study help us in that further step, whether it can predict which ones would recur, either asymptomatic or symptomatic?
Yeah, so not based on the results that I presented now, but we have actually looked in RePORT Brazil, for example. We've looked in other cohorts as well to see whether, for example, transcriptomic signatures at the end of treatment or during treatment are predictive of poor outcome, including treatment failure or recurrence. And so what we found is that that is the case. So there is a RePORT Brazil paper that's currently out as a preprint that's under submission, where some of these transcriptomic signatures that were actually discovered as TB biomarkers, as diagnostic biomarkers, and those could separate, in some cases, people who are at risk of death, in fact. That was an interesting finding. Recurrence as well as treatment failure. I will say, though, that we've looked at this in a number of different cohorts, and it's not necessarily consistent between cohorts. So, for example, Fani Malherbe, who I think was in the room earlier and may still be here, presented the PREDICT trial earlier today, the outcomes of the PREDICT trial, and in that cohort, or in that cohort, we looked at the same thing, and there we did not find that transcriptomic signatures could predict relapse. And so we don't quite understand why it is that in some cohorts it looks better than in others. I think it's probably got to do with the underlying population, the selection criteria for participants who are enrolled, the severity of disease of these people, etc. So more work needs to be done.
Thank you.
The differences in ethnicity also play a role, inherent genetic differences, because we are seeing that they do have a role to play in
yeah, I'll let Felipe answer that, or Bruno maybe, but I'm sure that plays a role.
So we are actually end of our time is up, but if there are any questions, we can take. I think everybody's tired now. And hungry as well. So thank you for that very interactive session, as much as we could at this end of the day. Thank you very much to all the speakers.